Tired of studying physics longer, but want to learn physics in a few minutes? This video is for you. Hey guys, welcome to our quick physics tutorial wherein we will answer physics problems step by step. In this tutorial, develop your analytical skills in a matter of 10 minutes. Improve your comprehension in physics concepts. Study at your own pace and study at your best convenient time. Please don't forget to hit the subscribe button below and click the bell for more updates. See you in a bit. Ready? Let's begin. This problem is about finding the instantaneous velocity of a particle. A particle moves along x-axis and varies in time according to the expression x equal to 2t squared, where x is in meters and t is in seconds. Evaluate its position at t equal to 3 seconds and t equal to 3 seconds plus delta t. Letter C. Evaluate its instantaneous velocity at t equal to 3 seconds. Step 1. Identify the given data. In here, the problem has given an expression of position of a particle as a function of time. Since x is in meters, we want to put necessary units on the right side for our expression to make sense. Step 2. Substitute the given values to answer letter A. Take note that the initial time here is 3 seconds. Plugging the 3 seconds time to the expression of position, we now get the initial position to be 18 meters. Step 3 is quite similar to step 2. We plug in the given time, 3 seconds plus delta t, to the expression of position. We now expand the square using the algebraic identity above, resulting to 9s squared plus 6s delta t plus delta t squared. Expanding the equation, we get 18 meters plus 12 meters per second delta t plus 2 meters per square second delta t squared. Subtracting initial x from final x, we get 12 meters per second delta t plus 2 meters per square second delta t squared. Step 4. Evaluate the instantaneous velocity at 3 seconds. Recall that the instantaneous velocity is dx dt, equal to the limit of delta x over delta t as delta t approaches 0. Plugging in delta x or xf minus xi expression, we get this. Cancelling delta t, we get 12 meters per second plus 2 meters per square second delta t. As delta t approaches 0, the instantaneous velocity would be 12 meters per second. Another option of finding the instantaneous velocity at a certain point is by getting the derivative of position over time. In here, we plug in the given expression of position to the derivative. Since 2 meters per square second is constant, we move this out from the parentheses, evaluating only the derivative of t squared. For this derivative, we bring down exponent 2 and subtract the exponent to 1. We now have 2 meters per square second times 2t. Substituting 3 seconds time to t, we get this. By simplifying, we now have 12 meters per second as our instantaneous velocity at 3 seconds time, which is the same answer from the previous technique. What's the difference between average velocity and instantaneous velocity? Let's have a sample graph of a particle with increasing velocity. Say a particle travels from xa to xb with time ta to tb respectively. We name their intervals delta x and delta t. Recall that the average velocity is equal to the change in position over change in time. Rearranging it, we get delta x equal to velocity times delta t. Now recall the linear equation, which is just y equals mx plus b, where m is the slope and b is the y-intercept of the graph. So that now we can say that the velocity could be the slope of the graph. Notice that at two different points, they have different slopes as well. The point at xb has a more stiff slope than xa, which means that the velocity at xb has a greater velocity than that of xa. Now, if this is the average velocity, the instantaneous velocity is dx dt. It is also expressed as the limit of delta x over delta t as delta t approaches 0. Simply put, if I want to get the instantaneous velocity at the middle point, I will have to shorten the interval such that the interval is very, very close to the exact point, meaning that the time interval approaches 0. And so the velocity at that specific point is called the instantaneous velocity. Thus, the average velocity is the velocity over an interval, while instantaneous velocity is the exact velocity at the particular point. Let us have a little exercise. Using the same problem, except for x equal to 1.5 t squared expression of position, evaluate the following. Just follow the previous steps and you will get the same correct answer. And we're done! Thank you for watching! Please don't forget to hit the subscribe button below and hit the bell for more quick physics tutorials. Like and follow us on our Facebook page. See ya!